Hello everyone. Today I will present See Beyond, benchmarking MLM's visual relational reasoning ability. MLMs look strong on perception and language, yet become fragile when explicit multi-object relations are required. So we proposed a controlled benchmark that isolates visual relational reasoning. Before we begin, why relational reasoning is important? Because it underpins intelligent behavior. Understanding how entities relate in space and attributes, not just naming them instead. And in these photos, dataset bias let models guess instead of reason. So we therefore remove semantic priors and probe relations directly in controlled abstract scenes. The key message is that we need a bias-minimized diagnostic benchmark focusing on relations. And we proposed two questions. Do relational objects measurably affect model reasoning? And how do attribute combinations change difficulty? We built CAPTCHA-style geometric scenes. Each scene has 7 to 10 objects to minimize semantic priors, and the questions are designed to have clear answers. We finally construct about 460 image question pairs split into non-relational and relational tasks with 3 difficulty levels. And attributes are color, shape, and size. And we also use set of mark and tool to label each object for consistent reference. Next, a quick view of the benchmark structure. We use abstracted scenes with numbered objects, each described by size, shape, and color. Difficulty scales with how many attributes must be bound, from 1 to 3. Non-relational questions pick a target from these attributes, while relational questions compare objects and can include left, right, front, and behind. The model filters by the clues, compares when needed, and then verifies the final choice. Then, in our experimental setup, we evaluate 6 major representative MLMs. We report accuracy as our metric, comparing the non-relational and relational subsets. We also conducted an ablation study to explore the contribution of the set of mark. On the left chart, you see non-relational performance. The average sits around 82%. On the right chart, we switch to relational tasks. Accuracy drops to about 64% on average, a decrease of roughly 22 points. Even the strongest model, GPT-4o, falls from about 19 to about 75. This pattern is consistent across models, which means relational reasoning is still a clear challenge. Then look at the left table first. Adding set of mark numbers for object indexing lifts the average from about 24% to about 64% and makes answers easier to evaluate. Now the right table. Occlusion and size comparison are the hardest subsets. With averages in the high 30s, even the top models only reach the middle 50s or low 60s here. These results suggest 2 weaknesses. Models struggle to maintain object-level memory under occlusion, and they suggest the struggle with fine-grained size comparison. Now we'll give visual examples for the hard cases. On the left image, an occlusion query asks for an object with the same shape to the right of a reference. Part of the target is hidden, which stresses persistent object representation. And on the right image, a size ranking query asks for the second largest object. This requires precise comparison rather than simple attribute reading. These are exactly the situations where the models fail most often. And the takeaway is simple. Current multimodal LLMs are not yet robust visual relational reasoners. Promising directions include explicit relation modules, object-centric memory, and encoders that are robust to occlusion. And VRR Bench serves as a focused diagnostic testbed to track progress on these challenges. And our presentation is over. Thank you for all you watching.